Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the general relations for du and dH. Let's firstly talk about the general relations of specific internal energy change. Similar to the derivation of entropy change, du can be derived from different independent properties, or three ds equations can be substituted respectively into the du equation according to the basic thermodynamic equation. Obviously, the second way is much easier as shown below. The first Gibbs equation is the first ds equation which has been derived is substituting ds to the du equation, then the first equation of du is. Similarly, the second and the third equations of du can be obtained when the second and the third ds equations are substituted into the first Gibbs equation. The second equation of du is the third equation of du is. Of the three du equations, the first du equation is the simplest and most useful. When calculating the change of specific internal energy, it's best to choose T and V as independent properties. The first equation of du can also be derived from the total differential. With the natural variables of T and V, the total differential then is. Using the definition of Cv, the total differential can be expressed as with the natural variables of T and V, the total differential then is. Substituting the total differential of ds into the first Gibbs equation yields the total differential of du is. Comparing these two total differentials of du gives. Using the third Maxwell relation, we then have. Then again, the first equation of du can be expressed as. Now, let's talk about the general relations of specific enthalpy change. The general relations for dH are determined in exactly the same manner as those for du. That is, three ds equations can be substituted respectively into the dH equation according to the basic thermodynamic equation. The first Gibbs equation is. In this equation, ds can be expressed by the first ds equation, which has been derived, and dp should be expressed according to the natural variables of t and v, that is, p equals p t v. Now, substituting the first ds equation and the exact differential of pressure into the second Gibbs equation, we obtain the first equation of dH. Similarly, substituting the second dS equation into the second Gibbs equation, we obtain the second equation of dH. Continually, substituting the third dS equation into the second Gibbs equation, we obtain the third equation of dH. Three general equations of specific enthalpy change dH are summarized as: obviously, the second dH equation is the simplest among the three. Therefore, when calculating the specific enthalpy change, it's best to choose T and P as independent properties. The equations are universal, not only valid for any gas, but also for liquids and solids. Okay, that's all for this task. Thank you very much and see you next time.